ओके, तो एक्वस इलेक्ट्रोलाइट को हम डिस्कस करने लगे हैं यूजिंग graphite electrodes. Graphite is the form of carbon which conducts electricity. And why we use graphite as an electrode? Because graphite is unreactive, very good, and allows the electricity to pass through. It conducts electricity but does not react. That's why we are using graphite electrodes. Okay. Now, what does an aqueous electrolyte mean? If you recall, electrolyte are water electrolyte are the compounds which can conduct electricity when molten or aqueous, right? Mm-hmm. So when it dissolved in water, then we call it aqueous. Okay. So what happens in aqueous? Okay, if I ask about molten sodium chloride, then what ions molten sodium chloride have? What ions are present in molten sodium chloride, Manahil? Yeah, it's NaCl. So what are the ions? The sodium ion and chloride ion. In the same way, if I talk about molten zinc iodide, so there is a zinc ion and iodide ion. If I talk about molten copper sulfate, so there are copper ions and sulfate ions. But now as it's aqueous, so it means that we have dissolved it in water. So when we dissolve it in water, so in this electrolyte, not just only broken down into ions, but water also ionizes to form ions. Water also broken down, and water forms hydrogen ion and hydroxide ion. So beside the formation of the ions from the electrolyte, these two ions are also formed. Okay, is this clear? So, for example, now there is a aqueous sodium electrolyte, sodium chloride. So in this aqueous sodium chloride, we have a sodium ion and chloride ion. But beside this sodium ion and chloride ion, we, as it is aqueous, so it have a hydrogen ions and hydroxide ions as well. Is this understandable? Okay. In the same way, when we talk about aqueous copper sulfate, so as it's aqueous, it contains copper ions and sulfate ions. Along with these two, they also contain hydrogen ions and the hydroxide ions. But when we talk about molten sodium chloride or molten copper sulfate, so they have only these two ions, one positive ion and one negative ion. But in aqueous electrolyte, there are two positive ions and there are two negative ions as well. Is this understandable to all of you? Okay, note this down. Discuss further. What is your full name? Aisha Ahmed. Okay. Assalamualaikum, Aisha.
Walaikum assalam, sir.
Okay, so today we are going to discuss the electrolysis when we use aqueous electrolyte. So aqueous electrolyte is basically when we dissolve the electrolyte in water. You are Mustafa. Sami is not present. Okay. So when we dissolve aqueous electrolyte in water, so electrolyte is all forms ions, but beside electrolyte, the water also forms ions. So if you recall from the previous graph, you can see when there is a molten sodium chloride, we have only sodium ion and chloride ion, only these ions are there. But when I use aqueous sodium chloride, so there are sodium and chloride ions, but beside these ions, there are hydrogen ions and hydroxide ions as well because of water. Is this understandable? So when the electrolyte is molten, it's just liquid. It contains two ions, one positive ion and one negative ion. But when it's aqueous, it contains two positive ions, one positive ion from electrolyte, that is sodium ion in this case, and a hydrogen ion from water. In the same way, it contains two negative ions, a chloride ion from the electrolyte as it's sodium chloride, and hydroxide ion from the water. In the other case, where we have taken aqueous copper sulfate, on adding electrolyte in water. Yes, Khatija?
Sir, in copper sulfate, you have written first that is liquid form and then it is split into aqueous form. So can you please tell the reason behind it?
Sorry, can you repeat?
Sir, in copper sulfate, okay, now you have corrected it.
Yeah, it's a error. Yes, everyone completed. Good, good, good. Yes, Manahil, did you understand? Yes, Aisha. Okay. Yes, Rohit. Yes, Khatija and Aisha Abdul Ghani.
Yes, sir.
Okay. So which ion is reduced at cathode? No, I'm just asking from the previous thing that we have learned that cation is going to reduce at cathode. Why you said hydrogen? Less reactive. Yeah. So we always refer to the when see in this case as now there are two positive ions, right? Here there is a sodium ion and a hydrogen ion. And in the same way, here we have a copper ion and the hydrogen ion. So it means that now there are two types of positive ions. So out of these two, only one is going to only one ion is going to undergo reduction at cathode. In the same way, out of these two, only one ion is going to oxidize at anode. So you have to understand out of the two ions, which ion is going to reduce at cathode and which ion is going to oxidize at anode. In this way, it's very simple because there is a one positive ion and one negative ion. So obviously, sodium ion will reduce at cathode and chloride ion will oxidize at anode, right? These were the cases which we discussed in the last class. Yes, done, Mustafa? Yes. Sir. Yes. Okay. Yeah, what I was saying, so now in the aqueous electrolyte, we have a two ions, two type of positive ions. So we know that ions are going to reduce at cathode, but there are two ions, so we have to understand this, that out of these two, which one is going to reduce at cathode first, right? In the same way, there are two anions, which are and anions are oxidized at anode. So we have to understand this, that out of these two, which anion is going to oxidize at anode. In the previous case, we did in the last class, it's very simple because there is a one positive ion, so it easily oxidizes, reduce at cathode, and one negative ion, which is easily oxidized at anode. If you guys have any question from here, you guys can ask. No, we will discuss it. Wait.
Sir,
Yes.
sir, in the definition, it is written that electrolyte also ionizes the water to some extent. So
Yeah.
water itself ionizes itself.
No, this thing over here occurs due to the presence of electrolyte in water. Otherwise, water stays as H2O only.
Okay.
Okay. Now, the first case. First, understand this. Then we will discuss it later. Then we can note down. Okay. Yeah, that's fine. Yeah. So at cathode, this is the reactivity series that we have also studied when we did metals. This reactivity series, when we move down the reactivity series, the reactivity of these elements decreases, and examiner does not give you this reactivity series, so you have to memorize these elements in the same sequence. That first is sodium, then the first is potassium, then sodium, calcium, magnesium, aluminium, zinc, lead, zinc, iron, lead, hydrogen, copper, mercury, silver, gold, and platinum. So as we move down, the reactivity of these elements decreases. Okay, tell me, the one which is more reactive, if the element is more reactive, then what will be its preferred form to stay? Its ion form or element form? I am repeating my question. The one which is more reactive, it will preferably stay in its ion form or element form. Ion form, because it is reactive, so it want to be stay as a ion, because ions are always the part of the compound. And the one which is less reactive is preferred to get to become element. Is this understandable? Yes, Aisha, Abdul Ghani, and Khatija, is this point is clear?
Sir, can you please explain this point again?
Yeah. What I am saying, that if the element is reactive, so its preferred form is ion form, because as it's reactive, so it doesn't stay in its element form, right?
Yes, sir.
And the element which is less reactive, its preferred form is its element form, not ionic form. Is this point is clear? Okay.
Yes, sir.
Now, let's take an example of aqueous sodium chloride. So, in aqueous sodium chloride, there are two ions. There are two positive ions. One is sodium ion and the other one is hydrogen ion. So, if you see the sodium and the hydrogen, out of these two, which one is more reactive? So, what
Sodium.
is the preferred state of sodium? It's ion form or element form? And what will be the
Ion form.
state of hydrogen? So, it means at cathode, hydrogen will go and form hydrogen gas because its preferred form is its element form, not ion form. So for a positive ion, we always look for the ion which is less reactive is going to reduce at cathode first. So the very simple rule is that if we have any aqueous electrolyte, listen it carefully, it is easy to remember. If we have any electrolyte in aqueous form which have any one of these ions, in that case, only hydrogen ion is going to reduce at cathode. No other ion will reduce at cathode. Is this point is understandable? And if the aqueous electrolyte have these ions, then in this case, hydrogen is more reactive, so hydrogen will not get reduced at cathode. These ions are going to reduce at cathode. So I have shown you the example. The first example is I have taken all these compounds in the aqueous form. So when there are all these compounds in the aqueous form, all these compounds have a cations which are from the elements which are above hydrogen in the reactivity series. So the hydrogen ion will reduce at cathode and we are going to observe a bubbles of a colorless gas. And
hydrogen reduce over like
yes, if hydrogen, for example, if I am doing the electrolysis of aqueous sodium chloride, so first hydrogen ion will start to reduce at cathode and form hydrogen. But as when all the hydrogen ions are finished, then sodium starts reducing. But when there is a hydrogen over there, sodium ion will not reduce. So we always write the equation which happens first. Okay, and we ignore the one which is going to be happen later. Now, here I have taken aqueous copper sulfate. The copper ion is below hydrogen in reactivity series, so that's why copper ions are reduced at cathode to form copper metal and pink solid deposits. Is this clear?
Yes.
Yes. Yes, Khatija and Aisha Abdul Ghani.
Yes, sir.
Okay. Now copy this quickly.
तो आपने जो highlight कर दी मुझे आपने बताया था कि hydrogen को release करने
So see, there is a hydrogen, all the above hydrogen. It is mentioned over there, and I have written over here as well. If anyone of you have any query, you guys can ask. What's your opinion? Aqueous. Where? Ag, it's mercury. Mercury, Ag silver, Au gold, Pt platinum. So how many of you memorized the reactivity series? Okay. What about? Okay. What about you, Manahib? पूरी कर लें जल्दी. आपको याद है मुस्तफा? कब करेंगे? जी सबने कंप्लीट कर लिया? ओके.
Will they be carbon above in the reactor?
Yeah, but we do not mention it over here. It is because we are right now talking about electrolysis. So in electrolysis, we just talk about ions, so there is no carbon ion. We show it when we discuss the extraction of metals, and it is between aluminium and zinc. So where we show it because where it is used for the purpose of extraction. Okay, yes, everybody done till here? Yes, Aisha Abdul Ghani and Khatija?
Yes.
Okay, now reaction at anode. So it is a little different. Okay, on cathode, we decided the ion which is going to reduce is due to its lower reactivity, right? That's what we have discussed. That the two positive ions among between these two, the one which is of lesser reactivity undergo reduction at cathode. But at anode, there are two different scenarios. We look for the amount. The solution can be either diluted or the solution can be either concentrated. What is the difference between diluted and concentrated?
Diluted is aqueous.
Both are aqueous. It's solution, so it means it's aqueous. Yes. Yes, Khatija?
Sir, dilute means more water, concentrated means less water.
Good. Or you can say actually the amount of water is same, but diluted means having a lesser amount of solute in it, and concentrated means having a greater or larger amount of solute in it. So if the solution have a comparatively larger amount of solute dissolved in it, then it is considered as a concentrated solution, and the solution having a lesser amount of solute dissolved in it referred as a diluted solution. Is this clear? Okay. Now, in diluted solution, remember, if it is written diluted solution, so no matter what anions are present from electrolyte, only the anion which is from water, that is hydroxide, it is going to oxidize, forming oxygen, water, and losing 4 electrons. So it doesn't matter whatever the anion is from electrolyte, if it is when the solution is diluted. So only this reaction would occur at anode. Is this point is clear? Yes, Khatija and Aisha.
Yes.
Okay. Now, if the solution is concentrated, means having a larger amount of solute, then if the electrolyte contain chloride, bromide, or iodide, then these ions are going to oxidize at anode instead of hydroxide ion. It happens when the solution is concentrated. So see, you know all these equations, we did it in the last class. The only difference is where the state symbols are molten and gases, but here the state symbols are aqueous and okay. The other thing, there are observations as well. Now the reaction are actually taking place at room temperature. That's why bromine is not formed as a gas, because we are doing for aqueous electrolyte, and for aqueous electrolyte there is no need of heating, right? In the previous class we discussed the electrolysis of molten electrolyte where heat is needed. So that's why the bromine and iodine forming over there are also gases. But here they form as an aqueous and the iodine as a solid and aqueous. Is this clear? Now, if the examiner, for example, didn't mention whether the solution is concentrated and diluted, then what we can consider it? We always consider it as a concentrated. Okay, if the examiner didn't mention it, just says, for example, aqueous sodium chloride, so it means that is concentrated sodium chloride. Okay, now if there are a nitrate or sulfate ions in the solution, if for example copper 2 sulfate like iron nitrate, so whether the solution is diluted or concentrated, we always get hydroxide ions are being oxidized at anode. So the only case when the other ions are oxidized at anode is concentrated and contains chloride, bromide, or iodide. Then these ions are going to oxidize at anode. Otherwise, beside this, if there is any other electrolyte, we always have a hydroxide ion being undergoing oxidation at anode. Is this clear? Yes, Khatija.
Yes, sir.
Okay. Okay, complete this.
Sir.
Yes, Khatija.
सर आई वांट टू आस्क कि जो है जो ऑक्सीजन जो बन रही है मतलब इसमें हीटिंग प्रोवाइड नहीं हो रही है बट स्टिल द गैस इज फॉर्मिंग
Because at room temperature, oxygen is a gas. That's why it's gas. See, chlorine forms over here as a gas because it's at room temperature. Chlorine is a gas. Bromine is basically a liquid at room temperature. So as bromine forms, it gets dissolved, and that's why it's aqueous. And iodine can be written as aqueous or solid because it's solid at room temperature. So you are sometimes going to observe a gray-black solid, or you are going to observe as it gets dissolved, the solution turns brown.
Okay, sir. And sir, if in the question the dilute and concentrated is not written, so can we not choose the molten instead of concentrated?
No, if they say it's aqueous solution, for example, they said aqueous sodium chloride. So how can you consider it as a molten? It means it's a
Okay.
solid. So we consider it as a concentrated. Okay?
Okay, sir. Yes.
Okay. Now, have a look at this question. If you see this question, completely based on the aqueous solutions. See, all are aqueous solutions. In the first case, if you see, in the first case, in the first two rows, they have actually provided you the whole thing that how you have to answer it. If you look at, in the first, we have potassium nitrate in the first row, right? Dilute potassium nitrate. And then they have mentioned the ions as it's potassium nitrate. So there is a potassium ion and the nitrate ion. But it's a aqueous, so that's why it has hydrogen ion and hydroxide ion as well. Then product at anode, so see, it's a dilute, so it means which ion undergo oxidation at anode? No.
OH.
Or hydroxide ion. The reactivity is for cation, cathode, not for anode. For anode, we decide on whether it's diluted or concentrated, right? So it's a diluted, so it means hydroxide undergo oxidation at anode, and that's why you are getting oxygen. Now there is on cathode there are two ions, cations, potassium and hydrogen. So if you look at the reactivity again, potassium is at the top of the reactivity series and hydrogen is in the middle. So that's why hydrogen ion reduces and form hydrogen gas. Is this clear? Okay, then in the next case, see now it's a concentrated, and that's why we are not getting oxygen, but we are getting chlorine. And again, at cathode, sodium is above hydrogen, so that's why hydrogen has a lower reactivity, so that's why at cathode hydrogen is formed. Now in the third case, they are giving you dilute copper to sulfate. So, and they have mentioned you the ions. Yes, Manali, can you tell me what will be the product at cathode? Look at the reactivity series, position of hydrogen and copper.
Copper.
Yes, copper, because copper is just below hydrogen. So, right? And now can you tell me, Manali, what will form that anode? For anode, you have just did it at the last. OH minus, but what you will write over here? Oxygen. See, because they are asking you the product, they are not asking you the ion which is going to oxidize at anode. So that is one misconception that normally students do, that they just write cathode, and instead of seeing that they are asking for the product, we will usually write the ions. So if you are going to write the ions, whether those ions are the correct, but you are not going to get the marks because they didn't ask you for the ions, they are asking for the product. So yes, you were right. Hydroxide ion is going to oxidize at anode, but then the product will be oxygen. Okay. Can anybody recall the formula of sulfuric acid?
H2SO4.
Yes, Khatija? H2SO4. So what ions are going to be over here? SO4 2 minus ion. What else? Hydrogen plus ion and OH minus ion. That's it, because hydrogen ion is in acid as well as in water as well. And they have given you the products. So, is this understandable?
Yes.
Okay. Now look at this table. Now who is going to tell me the answers? Yes, Mustafa, for the first row. Product formed at positive electrode. So if the electrode is positive, oxygen, very good. So the negative ion would be attracted towards the positive electrode. And as it's a sulfate, so we discussed that whenever there is a sulfate and nitrate, there is always hydroxide ion. And at negative electrode, copper, very good. In the second row, they have given you all. Now the third row is, I think, very easy because it's molten. So at positive electrode, bromine, very good, Rodale. And at negative electrode, lead. Is this clear? Yes, Khatija and Aisha Abdul Ghani?
Yes, sir.
Okay. Now, see, here they have asked you the equations, how you will write the equation. See, they ask when concentrated aqueous sodium chloride. So, see, chloride ion, aqueous and concentrated. So, we have discussed earlier, if the concentrated solution is there and it contains chloride, bromide, and iodide, then these are going to oxidize at anode, forming chlorine, bromine, and iodine. Right? So, chlorine is formed at positive electrode, they have told you as well. And hydrogen at negative electrode. Construct the ionic equation to show the formation of chlorine at positive electrode. We have practiced this in the last class as well, these equations. Is this clear?
Yes.
Okay. Now, and then they are asking, explain why hydrogen is formed at negative electrode. So the reason is same that we have discussed, because it is lower in reactivity series than sodium. So you just need to write this only. Or you can write this that it is lesser reactive than sodium. That will be the answer. Is this clear? Okay. Okay, name a metal manufactured by the electrolysis of molten ionic compound. Okay, that is the thing that we are going to discuss it in, extraction of metals. But the easy thing is to, as Aman mentioned, that the carbon, we didn't mention over here carbon, but the actual position, if we look for a carbon in this reactivity series, is over here. So all the metals which are above carbon in the reactivity series are going to be extracted or manufactured by the electrolysis method. So it means for that you can answer any one out of these five. It will be marked as correct, whether you can write potassium, whether you can write sodium, whether you can write calcium, whether you can write aluminium, all are going to be considered as correct. Is this clear to all of you?
Yes.
Question still here? Okay, so the next is if you see over here, in the next class we will continuing this. We discuss the electrolysis of aqueous compounds and ionic and molten compounds using inert electrodes. Now we are going to see that how elective electrodes going to change the electrolysis. So that's what we are going to do in our next class. Okay. So, okay, take care, everyone. Okay.
Allah Hafiz, sir.
Allah Hafiz.